Hi, everyone. This is Angela Chen, the co-founder and CEO of Esclabs. Welcome to the final installment of the Esclabs Demo Day for our Cohort 6 Data Science Fellows. Today's theme is the future of climate change solution with data, a topic that I'm personally very excited about. Let me give you a quick introduction for those who might not know Esclabs, and also share with you how the event will go. Esclabs is a data upskilling school based in Manila, and our mission is to democratize the future of work through data skills and education. Today's event is a part of a series of demo days which will showcase the work of our data science fellows who completed a 12-week part-time program to launch their careers in data science. The fellowship is not just about skills building. It's also a community that's curious about how to use data to advance innovation and impact. Many of our fellows will go on to work in industry. In fact, through new interview guarantee partnerships we've introduced this year, fellows can choose to have guaranteed interviews at innovative companies like Quadex, Home Credit, Kumu, and more. But before they arrive at that future, they're going back to one of the reasons they wanted to learn data in the first place, which is to build a world. This demo day is inspired by cult classic Back to the Future, where we envision how data will be a big part of our future lives. Through innovation in the startup ecosystem, through better governance and policy, and contribution to COVID and climate change solutions, all through projects which provide a unique Philippines context. Today, we're welcoming our last speaker of the series, David Dow, who is an expert on today's theme. David is currently completing his PhD at ETH Zurich, where he's building AI and data systems for sustainable development. David is leading the Climate and AI Initiative at DS3 Lab, mapping the ethical use of AI, and directing the Kara Research Project with Stanford and UC Berkeley. David is also the founder of Gain Forest, a nonprofit grantee of Microsoft's AI for Earth program, which leverages decentralized technology to prevent deforestation. David is also a global shaper at the World Economic Forum and a climate leader with Climate Reality Project. Well, David is not able to be with us live today due to time zone differences. He has sent in questions for the projects, which will help moderate alongside Julia Lass, who is representing the Esclabs education team. And before we kick off, David has prepared a special presentation for us to learn more about the current research he's conducting and what's at the cutting edge of the intersection between AI and climate change research.
Thank you so much for the invitation to give a talk at this really great event. I can't wait. Unfortunately, I can't be here live right now. As you can see, this background is not virtual. I'm right now in South America on a restoration project. So please excuse me if you see or hear any bird sounds or thunderstorms. It's the rainforest is very known to be rainy. But I hope this talk will be useful for you guys. And I hope it inspires some of you to look into data science to take more action against climate change. So let me start sharing my screen. So I'm David Dow, and I'm a researcher at ETH Zurich, where I lead a climate AI initiative, where we're working towards using artificial intelligence to help restore the natural world. So let's get started. So for the beginning, I prepared some small video clip from a fellow conservationist.
So ever since high school, I've basically known that I need to come back to this area and try to protect it, right? The way I phrase it every time is for this place to get degraded and for it to disappear would definitely be the regret of my lifetime. That's for sure.
That is the voice of Anne, who is the managing trustee of Masungi Geo Reserve, very close to Manila metropolitan area. So Anne has been managing this really amazing Geo Reserve, and she's been facing a lot of current backlash and illegal deforestation, as well as in general problems that the conservationist has to face. And so she's one of my big heroes. Being in the field means working for the environment and against changes in climate change. Is pretty cool in Europe, where I'm from originally. But it is not just cool in the Philippines or in countries which nature is at stake, but also very dangerous job, which many of us Europeans don't understand. So people working on this really important field work are the real heroes, and this talk will be about them and how to empower them. So let's hear what she has to say more.
What I said, the Philippines is one of the most vulnerable countries to climate change. And I've already enumerated a while ago how things impact us here on the ground. The problem with talking about things happening on the ground is it can make you quite emotional. But, you know, climate change, some things, I can restore things here, but there are things like climate change that really requires collective action. And action from other countries affect us still on the ground, right? So I've had several indigenous park rangers who we'd often send back to their land in October so they can plant their crops. But because of climate change, because their crops can't grow anymore, then they lose that part of, their culture and their sources of income.
So climate change affects us all, especially the fact that illegal deforestation, the way we treat nature, is a contributing factor towards climate change. So if you look at it, not only does climate change cause crops to not grow anymore and nature and forests to deteriorate, you see forest fires everywhere, but also the fact that we are cutting down primary forests like our rainforest everywhere in the world releases carbon emissions. Many experts expect that it's up to 25% of global emissions are just from tropical deforestation alone. So if you look at it, it would be among countries, the third largest country, even larger than the whole region of the European Union as an emitter. So it's a gigantic issue that not only is affected by climate change, but also causes climate change directly and the issues which people on the field have to face. It's a humanitarian crisis as well. So you heard already about the experiences Anne has been reporting, but the region I really care about in South America with indigenous people, they have been facing, due to deforestation, threatening conditions. Here, many leaders, indigenous leaders, people who speak up and try to protect their areas are getting attacked, endangered by people whose interests are against protecting the nature. So being an environmentalist and someone on the field is a very dangerous job. And unfortunately, we can't change what we can't measure, right? So people at this field, they need to report, they need to tell what is going on the field. And many times just measuring things is really, really hard. So what we at our lab are doing is trying to see if we can help them empower the measurement on the ground that is needed to create change. Right now, if you look at how measurement is done, for example, in deforestation, how, for example, restoration projects are measuring their progress, you will have to hire actually someone to come over and with a stick and a measurement tape and go to each single tree and estimate its biomass. So that is super expensive, $300 per hectare. You can imagine that a small scale farm owner cannot afford this. And it's also super slow. So what we are doing in our research is to combine digital methods such as satellite monitoring, also advanced technologies such as drone monitoring and good old field monitoring, but with a twist, as you can see in a second, to create as much data as possible, fuse them all together and create a very comprehensive report for decision makers to act on. So here, for example, one of the very first research we've done at our lab is to try to predict deforestation. There's unfortunately to say, a lot of deforestation data out there. So we trained it on past historical data and wanted to see if that model actually also works on future data. As you can see, our model on the left side, here's an area of deforestation that basically is in the Amazon rainforest. And pink, you can see areas which is getting cut down. And on the right is our deforestation model forecast that tells rangers and policymakers where to go next, where to expect the next wave of tree cutters to go. We can also advance this a little bit further. Here, this is work done by my colleague Björn Lütjens from MIT, where he shows that not only can we train to forecast risk areas, but we can also visualize future events such as flood generation. which fits really well right now because it's raining right now here. Just started to rain here. So flood generators help you basically visualize the effects of climate change directly for the decision makers to see, okay, what is the area that looked before and what is the area that looked afterwards. Lastly, machine learning-based carbon estimation is super important because if we don't need anyone to go to the field anymore, we don't need anyone to measure a tape, then if you just need to fly a drone above the forest cover and you get immediately carbon estimates out of this, carbon estimates allow landowners who own that land to get money for their land because storing carbon is pretty good for society, and nowadays that's what would bring you money. And of course, if you have an opportunity to do that on a large scale, and we're using drone data here, this would be really, really promising. So all these technologies I talked about will hopefully be open to conservationists because in the end, we can do fancy technologies, but if it doesn't come to the field, if it doesn't go to Anne, and if it doesn't go to people who are actually in need of these technologies to report changes, then it's all not really useful for them, right? So we're launching Restore, which is a foundation that provides all these technologies I talked about and more in June 5th. You can visit it under restore.eco, and hopefully that will help empower many, many more people to report changes of the environment in an easy way. This one is a really cool tree-based app I wanted to show you guys, where we also try to empower old-fashioned field-based measurements. Let me start the video.
Ecosystem restoration is gaining momentum and international buy-in as one of our primary responses to climate change and biodiversity loss. Already, millions of new trees are growing all over the world. But until now, we've been restricted in our ability to monitor and review the success of reforestation projects. Improved ground data will not only enable scientists to better evaluate forest restoration methods, it can also be used as evidence of restoration progress and, in time, could directly translate into payments for ecosystem services. Unfortunately, collecting forestry data is slow and expensive. But what if it was possible to share data on tree growth at the touch of a button? Tree App will allow users to share data about the species of the tree, its biomass, the carbon sequestered, and a whole host of other tree traits in a matter of seconds. And all you need is a smartphone and any card from your wallet. But first, we need your support. In order to finalize the app, we need some training data. Training data is a learning basis for the computer models that will power the app. The more on-the-ground training data we have, the more accurate the app will be. And it's this simple. Download the app and log in. Stand in front of your tree and hold a standard-sized wallet card in front of the trunk, touching the bark. This should be about 1.3 meters from the ground, making sure the entire wallet card and edges of the tree trunk are visible. Take a photo. Once you have a clear photo, using a tape measure, record the circumference of the part of the trunk you just photographed. Enter the circumference into the app and search for your species in the list. Complete the first tree. Repeat this from up to 3 different angles around the tree. Move on to the next tree and repeat for as many trees as possible. At the end of each session, find some stable internet and upload all of your pictures. And that's it. Once we have enough of this data, the app will be up and running. Then, all that you'll need to monitor trees in the future is a smartphone and a wallet card, anywhere in the world. Tree App presents an opportunity to revolutionize forest restoration, enabling more effective restoration strategies, while ensuring tree owners are recognized and rewarded for critical work they are doing.
We talked a lot about measurement now, but the sentence at the beginning was, we cannot change what we cannot measure. Let's talk about change. So how do we go from one thing, which is data science and measurement, towards real-world good impact that can actually have a positive effect towards people on the ground, local communities, indigenous people? So for that, many years ago, friends and I founded an organization called Gainforest, which is a nonprofit that combines blockchain-based incentives and blockchain-based assets with the measurements which we produce and which you've seen like so far in the first part of the talk. So let me have Nathaniel talk about what Gainforest is and how we can combine now one cool technology such as cryptocurrency with the things in AI which we developed.
So right now, people care a lot about conserving the rainforest in the Amazon. But there's a problem, which is that local industry can pay a lot more and to local indigenous people than conservationists to take over land. And so what the folks at Gainforest are doing, Gainforest is a new nonprofit, what they're doing is they're setting up a blockchain-based system so that if you are a person who cares about saving the rainforest, you can actually pledge money. You give the money into the blockchain-based system, and that money goes to indigenous communities. But it goes to the indigenous communities in the form of a smart contract. What's the smart contract? Well, what Gainforest does is they use satellite imagery data of the Earth. So remember, today, in today's world, we take satellite imagery data of the Earth multiple times a day, and it's incredibly accurate. And you can use machine learning and data analytics to analyze that satellite imagery data, and you can tell very precisely whether trees in a particular area are left alive. And if those trees are still there in 60 days, 90 days, 3 months, 6 months, different amounts of money pledged by donors automatically unlocks to the communities responsible for protecting those trees. And it means that it's much faster and easier and less expensive. There's less legal work involved to actually get money from the donors and the people who want to save the trees to the people who live in those communities and actually have the power on the ground to save them. So right now...
Oops. So Gainforest is basically crypto for good. We are creating the measurements we talked about and try to make it a digitized asset such that people on the ground, such as indigenous people, can profit from it. So we are very happy to announce our white paper release this Earth Day, 22nd of April. If you're interested in the concept, please check out gainforest.net to see and maybe also to help us create a social and just impact on the ground. The Kayapo people, we have been testing this approach for a little while, and as you can see, the Kayapo people here, the donations which Gainforest will receive will go directly for them to protect their forest areas in Brazil, where the payments are received through local supermarkets, as well as a network of partners which we establish on the ground. Yes, so you can change what you can't measure. So let's start with measurement and don't forget to change. Thank you so much for your attention.
Wow, what a cool overview from David, and also an awesome shout out to Masui, which is such a treasure for many of us, the urban dwellers in Manila. So one of the key themes from David's talk is based on this concept that you can't manage what you can measure. Right? So this is a very long-standing management concept that has really driven the business adoption of data and the analytical mindset of managers. And that's also what Data for Good is all about. So how can we apply the same rigor applied for industry to impact issues that might not attract the same level of talent? A key problem with sustainability is that you can measure something if you can't define it, right? So what is the value of a tree? That's somewhat been solved by things like carbon markets, but what is the value of a stream? What is the value of clean air? Or even what is the value of Masumi to people who live in Manila? What's so difficult about the work of conservationists is that nature, biodiversity, now they don't exist in silos. We are seeing them from the point of view of human systems. And so all of the environmental issues are actually being embedded in a complex social and economic system that humans have built. Our fellows are now beginning to scratch the surface of what are the possibilities of combining our knowledge of data science and our love for the environment. So now let me have Julia bring out our fellows. And before that, I also love to reintroduce our instructor, JC Peralta, who by day is a data scientist at Ayala, where he creates and deploys market forecasting models and provides weather and climate insights for power trading to enhance the competitiveness of the renewable energy sector in the country. But JC is also trained in climate science. He's worked extensively with climate big data, focused on the local dynamics and impacts of regional monsoons over the Philippines and in Southeast Asia. JC will be joining Julia for the live Q&A, which I hope our audience will also get to participate in. So now let me welcome Julia.
Thank you very much, Angela, for that introduction. With that, I would like to present now our fellows' contribution in addressing climate change problems. Our first presenter was very passionate in addressing a problem we are very familiar with in the Philippines, typhoons. She was very adamant in helping people affected by typhoons each year that she took on the challenge of doing an individual capstone project. Let's give a virtual applause for our first presenter for today on the geospatial analysis of evacuation centers done by Ms. Jessica Isidro.
Hello everyone, good afternoon. I am here to present my capstone project entitled Geospatial Analysis of Typhoon Evacuation Center Locations in Metro Manila. Located along the typhoon belt in the Pacific, the Philippines is visited by an average of 20 typhoons every year. But despite the yearly unpleasant visits of these typhoons, LGUs still do not have enough evacuation centers, and most of the evacuation centers do not adhere to the minimum design standard. But what do we mean by the evacuation center's minimum design standard? Here are the site selection criteria for evacuation centers from UNICEF. It measures the ideal size of the area, connection to basic utilities such as water and electricity, and mapping, but none about the actual structural design. Now let's take a deeper look at the evacuation centers in Metro Manila. I have grouped the evacuation centers into these categories. As you can see, most of them are schools. Second are covered basketball courts. And we have unknown. These are places tagged as evacuation centers, but the addresses are incomplete. They only tell you the subdivision name or the barangay name, but the exact location is unknown. There are also evacuation centers. So what do we get from this chart? Most of our evacuation centers are facilities that are being used day-to-day as schools, basketball courts, and so on. And then when the typhoon comes, these are converted to evacuation centers. Only 3 of them have the name evacuation centers on them. Now let's take a look at this image where the evacuation centers are mapped. UNICEF included that evacuation centers should have coordinates. Metro Manila has 631 evacuation centers, but only 390 of them can be found in Google Maps. This is because some of the addresses are incomplete. You may have noticed that only few are listed here in Manila and also in Quezon City. The objective of this project is to group the barangays based on their population density, flood hazard level, and number of evacuation centers to get which barangays are in need of evacuation centers. This is also to encourage the barangays to build an evacuation center, convert facilities to an evacuation center if they have low budget, or upgrading facilities for sustainability. This is the overview of the steps to achieve our objective. Number 1 is collection of data. Next is process the shape files or the geospatial data of Metro Manila so we can connect it to our regular data. Then we fit the combined dataset to our machine learning models. From there, we can form conclusions and recommendations. The first in our process is collecting the data. We have 4 main datasets. First one is the Metro Manila polygons, which contains the administrative boundaries of the barangay. Next is the list of evacuation centers, which are categorized and mapped earlier. Next is the 2015 population per barangay. And lastly, the flood hazard map from LIPAD. Some key numbers here. There are 1,706 barangays, and there are 631 evacuation centers in the metro, meaning there are 3 barangays sharing 1 evacuation center. Let's go to the flood map of LIPAD. It is categorized to 3, low, medium, and high according to height. To process this flood map and the Metro Manila polygons, I use the software QGIS for this activity. First is we get the barangay and the flood hazard map polygons. Second is we match the barangay polygons and the flood maps. Next is we use the method intersect from GeoPandas to check if the maps intersect with one another. And lastly, we merge the result to the PSA dataset. After merging, we can get the flood risk of the barangay if it is high, low, or medium, and the population density. Next step in our methodology is modeling. These are the unsupervised machine learning models tested for this project. This is to group the barangays as per the objective of this project. The most even grouping is from K-means model. So also the silhouette score from the K-means model is higher compared to the other models. So K-means will be used in this project. Here are the results. The slide is crowded, but let me explain. So this is the count of the barangays, first row. The second row is the flood hazard map. Third is the evacuation center. And fourth, lastly, is the average population density. For here, our cluster 1, there is 100% low and medium risk of flood and very low percentage of evacuation centers. For cluster 2, it has descending percentage from low, medium, and high, has 200% evacuation center, and has the lowest population density. For cluster 3, it has the higher percentage of flood risk compared to group 2 here, but has very low number of evacuation center and higher population density than group 2. Then for the last cluster, it only has medium risk. Also, for cluster 4, only has medium risk, also low percentage of evacuation center, but has the highest population density among the rest. If we group them by color, this is red, this is orange, yellow, and green. So based on those groupings, we can highlight the cities for prioritization. On the left are the cities of Metro Manila and the barangay grouping color mentioned earlier. So the top cities to be prioritized are Las Piñas, Quezon City, and Marikina. For Las Piñas, it is recommended that they check the 70 evacuation centers in the city if they are flood-proof. It is also recommended that they build sustainable evacuation centers with connection to water and electricity because 16 of them are basketball courts. And if they have additional budget, they can also build flood tunnels and spillways. For Quezon City, it is recommended that they build evacuation centers or have them listed to the master list of evacuation centers. And lastly, for Marikina, it is recommended that they check if the 22 evacuation centers in the city are flood-proof because most of them are near Marikina River. So these are the recommendations per group. For the priority group or the red group, they should plan to build evacuation centers or convert facilities into one. They should also consider the flood hazard risk of their barangays. The pangalawa or the second group has gymnasiums and schools as evacuation centers, but should build for those barangays without one. And also consider the flood hazard risk, same with the priority group mentioned. For the pagitan or the middle group, should build more sustainable evacuation centers because most of them are basketball courts. Lastly, for the prepared group, they should still check their evacuation center facility types as most of them are parking lots and open spaces. Lastly, I will leave you with this quote. So to all aspiring data scientists like me, let us encourage our government to improve. So let us make Philippines a better country to live in. Thank you.
Right, that was a great presentation, Jay. So congratulations on a successful presentation. So let me open the question and answer portion while we're waiting for questions from the audience together with JC here. So I guess my first question for you is something that I mentioned a while ago that I'm really curious about is that you're very passionate in doing this project, right? Because I know that you really wanted to do data for good. So can you share more with us your motivation on why you wanted to push through with this project, even despite knowing the challenges on working with a solo capstone? Hi Jay, I think we can't hear you. Can you check your audio? I think Hi Jay, I think we can't hear you. Can you check your audio?
Hello, can you hear me?
Yes, we can hear you now.
Yes, okay. I think there's something wrong with my audio, but I'm gonna answer Julia's question first. So around late 2020, it was the time of the application period of Escolab's Data Science Core 6. And it was also the time that a strong typhoon hit the country and many were displaced to evacuation centers because of heavy flooding. And I thought this might be a sign for me to do something, and why not make this capstone project, because it was really heartbreaking to see evacuation centers crammed with hundreds of Filipinos and diseases potentially spreading, not only COVID-19, but there's common flu and also skin infection and so on. I saw on TV one time that one evacuation center was not given food supplies because the local government did not know that there are people staying in that evacuation center. So this project also maps the evacuation centers. Actually, I have a web app in place, but it's too young and too raw for the audience to see right now. But post bootcamp, I will surely work on it and hopefully showcase this to the local government, which is the target of my project.
That is so nice to hear that you're inspired by, actual events happening. Yeah, yeah, we know that there's a lot of people affected by typhoons around the country every so often, especially during the typhoon season. So we have here a question from David that he sent online after watching your presentation. So he mentioned how he really likes how you connect the data science with policy, making it more relevant to decision makers. So his question is, in your analysis, did you notice any correlation with certain areas that have more coverage in evacuation centers compared to others? And what do you think are the factors why the evacuation centers are not evenly distributed within Metro Manila?
I think that the evacuation centers are not well placed in certain locations, for example, in some of the barangays, because probably I personally think that it's budget allocation. So I think Filipinos are very resilient, so that's what they're I think used to just go to a higher place and stay there, and that's just it. So maybe I think the main reason here is budget allocation. So I think this is the time for us to change that, since typhoon is coming every year. So I think aside from COVID-19, this is the time that the government can also prioritize that as well.
All right. So we have here with us JC, who's also, I know, worked on efforts as well in terms of disaster management, disaster relief. So JC, do you have questions for Jay?
Hi, Julia. Hi, everyone. Yes, I have questions for you. But before that, no, let me just highlight, as someone who had also experience handling geospatial data, especially geospatial text data, place names. What Jay did here is pretty much a lot of work. The cleaning, I could just imagine doing all those cleaning, for all the what's the number, J600 something barangays and how many places that you've checked, no? So doing that alone, well, I think not everyone could appreciate that, especially those uh, who haven't really gotten the chance to tackle geospatial data, no? So, well, this is more of a comment. No? You actually named the metric of the the basis that formed the, you call it, the classification of the barangays as flood hazard risk. If I may nitpick on that, no, well, those hazard and risk are probably, well, in common terms, parang synonymous to each other, but in disaster science, they mean a bit of, they have a difference, no. So there's this famous equation in disaster science. So it's risk equals hazard times exposure times vulnerability. So three elements that comprise risk. So what are those three? So hazard is the typhoon, the dangerous phenomenon, that whatever that is, may be an earthquake, pandemic, and so on. So that's the natural disaster. The exposure is how that's vulnerability. No? So exposure is how uh, the how the people are aware of the hazard in itself. So this is where uh, the LGU's interventions come in, and then the last factor would be vulnerability. So this would be the the state of the people that lie in the hazard zones. So this would be about their social status, the demography over that area. No, so hazard pertains exact specifically to just one of those factors, no? And then coupling that with the word risk seems a bit too random for me, no. But I get your point, no. Well, a better question would be, well, that's what I wanted to clarify now. So, you used unsupervised model to come up with these prioritization classifications. Am I right?
Sorry, I was not able to hear your question. Can you repeat it, please?
Okay, Jay, you used unsupervised model and the unsupervised model classification in coming up with your prioritization classifications, right? So I think Jay's trying to answer, but yeah, there's a bit of feedback. So let me just continue. No, so I think you did. And so well, the problem with unsupervised models, no, and is that, well, you let the model choose the categories basically. No, so what that would do is, okay, there's less intervention in the part of the modeler, but the risk is it would amplify existing patterns of bias, and if those biases turn out to be some form of injustice, like say in most famous example would be applying unsupervised model to credit policy, in that the biases may affect people of that has been historically affected by less lending, has been associated with less lending credibility, no. So in your case, no, what are those, would you like describe to us some features that would result to such biases in your model, or could you identify some sort of, yeah, would there be some biases that arise when you were seeing those when you were building your model? Was that clear, Jay?
Hello, JC. Thank you for that question. So for the biases, I was not actually able to get some of those, but I removed one of the main actually the main data, one of the main data that I got earlier in the process, which is, hello, can you hear me?
Yes, Jay, we can hear. Oh, now we can't. You're muted. There.
Hello, can you hear me?
Yes, now we can hear.
Hello? All right, I think there's some feedback on my end. Hello? Okay, I think there's something wrong with the audio, but let me answer JC's question first. So yeah, as mentioned earlier, one of the data that I actually removed from the modeling is elevation. I got it before in the process of the modeling, but yeah, I think it really messed up the data. So yeah, I think there was subjectivity to it, so that's why I removed it. So I used it because I did not use elevation, yeah, because it messed up with the data, but um, I still stick with the unsupervised machine learning models because it simply targets to group similar observations, which I think is sufficient to the objective of the project. If I manually group the barangays, it will add more subjectivity to the result. Um, for example, looking at Manila, I know that it's a crowded city and it's near waters, and also in the data there's no cut of barangay. So I think if I manually did that, I manually just filter the data and then group it by myself, it will definitely add more subjectivity to the process.
Jay, if I may help you flesh that out, no? So you actually had a slide, no, on site selections, no? So I think the bias that I see in this kind of data pipeline is the selection of the evacuation centers that go in the model. So if you'd notice, no, some of the I think a big chunk of the evacuation centers in your data set are in the flood prone areas, no? And I think plugging that into the model might ruin the recommendation, no? So definitely there needs to be some kind of filtering when you select those evacuation centers, no? You had the definition of a good site, no, in one of your slides, and I was just hoping that you have applied that, no. I think be uh this would enhance your recommendation, no? Only using those evacuation centers that fulfill the criteria of a good site for it would just better highlight the results, no, of your modeling, and it would get rid of, well, that bias of if it's just tagged as an evacuation center, then it is an evacuation center, no? So yeah, for when using unsupervised models, you might want to be more aware of our data sets, no? Because what you put in the model would just be amplified, no? So yeah, I think that's it, no. If
All right.
I think given more time, Jay would be able to work on it naman.
Right, thank you, JC. Yeah, that's very a good perspective, especially coming from, both as a data scientist and as a climate scientist. The equation you gave a while ago is very useful for any disaster management studies, right? And at the same time, so, we do know that that there's a lot of domain knowledge involved that could probably be added to the model to further improve it later on. But I guess there's a couple more questions from the audience, but before I jump to that question, I guess one thing I want to ask Jay is that I know that at this level of government, for those people who are not aware, like Jay's already credited a while ago that it's so hard to wrangle with the data, given that it's at the barangay level. But it's not also just like the messiness of the data, but also like there's so few data available at the barangay level, because even at the national government level, we are aware that it's not that persistent, it's not that clean. So I guess my question is, if you can improve your model by adding more features, let's say let's assume that we have an ideal government wherein the barangays are able to collect data that would be suited for our needs. What would be like some of your wish lists so that you can improve your model by adding features that they can provide?
Thank you for that question, Julia. For my wish list, probably, I have a few actually. One would be match names of the barangay, regardless if the data is coming from different government agencies, because I had really a problem on that. And then second would be the capacity and the amenities of each evacuation centers. There's actually one available, but it's incomplete. So if we have that, so we can compute how many can stay in that evacuation center, probably also considering social distancing, since COVID is still here. Yes, and also another one is a complete list of evacuation centers, because there's only a few listed for Quezon City and Manila, and their coordinates as well, so we can map. Next would be probably disaster risk management budget for each city and each barangay, if possible, to know if that is enough or not enough. And also the average evacuees per evacuation center, to know if those evacuation centers are being used and how many are people, going in that evacuation center. Yeah.
Thank you, Jay. So one last question from the audience. So you mentioned that, yeah, the people coming in the evacuation centers. So a question from the audience is, did you look at the accessibility of evacuation centers? So it's one thing to know the location, but is it even accessible? And if not, how do you propose to evaluate the accessibility of the evacuation centers in your model?
Oh, actually, that's a good one. Probably I would really like to add that to the next phase of my app, but as of the moment, was not able to touch it because due to time constraints. But yeah, I would really love to consider that for the next phase of my project.
All right, thank you very much, Jay. Yeah, I know that a lot of hard work went into doing this project, and and this is a start. There's a lot more that you can do, and I know that there's a lot of people willing to collaborate, especially those from our audience who've been asking a lot of curious questions about the model. Right, so thank you, Jay. So now we will transition to our next fellow, who probably did one of the most technical capstones for this cohort all by himself. So he's also very passionate when it comes to renewable energy. So let's welcome Jan Pasha, or Pash as we like to call him, who will be talking about predicting wind farm locations in the Philippines.
Good evening. I hope that you are doing well tonight. I am Jan Allen Pasha, and I will be discussing my capstone project, predicting candidate wind farm locations in the Philippines using time series modeling and spatial downscaling. But first, what is a wind farm? A wind farm is a group of machines which look like big electric fans but behave the opposite way. These machines are called wind turbines. Most wind turbines have the standard 3 blades which move when there is enough wind passing through the area. The movement rotates the generator inside, which in turn generates electricity. Why should you care about wind farms? According to a 2012 study published on the Journal of Industrial Ecology, wind energy produces just around 11 grams of carbon dioxide per kilowatt-hour of electricity generated. Coal's carbon footprint is almost 90 times larger than that of wind, while natural gas is more than 40 times larger. Imagine if the Philippines were to rely on wind as energy source instead of coal or natural gas. We could make an impact in curbing the amount of carbon emitted to our atmosphere. Fortunately, within the past decade, there have been 186 wind turbines or 11 wind farms commissioned and built in the country. At this point, the total installed capacity of all wind farms is around 460 megawatts. According to the AGEP, back in 2018, the wind farms produced almost 1,200 gigawatt-hour of electricity. Suppose an average Philippine household which consumes 200 kilowatt hours of electricity per month. The wind farm output back in 2018 equates to around 6 million households served that month. Since building a wind farm is a complex engineering project, there are several aspects considered to choose a good location, some of which are environmental, considering if a site is a wildlife reserve, economic, how budget will be procured for such a big project, social, where impact to communities in the adjacent areas are considered, and the most important of them all, the technical aspect. Under technical, there are land topography, geology, connectedness to a power grid, and lastly, behavior of wind. Aspects such as wind density and wind direction are considered, but several sources are pointing towards wind speed as the most important one. Using a mapping software application, the scientists involved are able to process these technical factors. This is the Global Wind Atlas. This map is the best example of an output of a mapping software application. To produce the detail in this map, a team of scientists collaborated to fine-tune the inputs to the software. The aim was to produce a global map, and such endeavor required a huge amount of computing power and ample research funding. Locations in red and orange are those with higher wind speed values. If I were a decision maker, these areas are where I would consider building wind farms. However, the wind data used here as input for the Philippine map were dated from 2008 to 2017. What if I want to plan for the future? Wind, as we all know, is a varying presence in an area. These are the questions that I would like to answer in this project. Can we make an updated map of wind speed values for the next 1 to 3 years? Does mapping the predictions help pinpoint a good location for a wind turbine farm? Is there merit to using a data model pipeline as an alternative process without compromising the quality of the results? The first 2 weeks involved getting the data, exploring it, cleaning it, and trying out the different time series models. The last 2 weeks involved the heavy lifting, where the bulk of the results will be lifted. As I mentioned earlier, I used the Global Wind Atlas map of the Philippines. It is a static image with at least 40 million pixels. Each pixel corresponds to a grid of 280 meters by 280 meters. After selecting only pixels with non-null values, I am able to generate a data frame of 22.4 million rows. With the help of my mentor, JC Peralta, I was able to get the dataset which the Global Wind Atlas team used to produce their maps. This is the ERA 5 data provided by the Copernicus.eu website. ERA 5 is a dataset of global climate variables such as ocean temperature, rate of evaporation, and wind components, to name a few. Unfortunately, this dataset has a lower resolution than the GWA map. Data is available as 28 kilometers by 28 kilometer grids, at least 100 times worse than the GWA map resolution. Fortunately, ERA 5 contains complete time-based data, which fits perfectly well with time series modeling. This is a plot of the wind speed values at two largely different grid sectors indicated by their center coordinates. The red line, somewhere in Antique, represents areas which have higher wind speed values, while the blue line, somewhere in Davao, represents areas which have lower wind speed values. Time series modeling is the usage of methods to process and analyze time-based observations. These modeling methods are used to predict future data points based on past data. First, the ERA 5 data is split into two. The training data are monthly observations dated from January 2008 to December 2017. This time range corresponds to the date range of the GWA map input. The training data will be used to configure our prediction models. The test data are monthly observations dated from January 2018 to December 2020. The splitting of data is done across the 3,195 available grids. The test data will serve as benchmark for the prediction models to determine how well they performed. The time series models I used were 4 versions of exponential moving average, 1 version of FB profit, and 2 versions of long short-term memory. These models were applied to the 3000 grids of the split Era 5 data and ran for a total of 17 hours with LSTM and FB profit consuming at least 95% of the time. How do I then decide which model to select as the best one? But first, what is LSTM? What are activation functions? Long short-term memory network is a neural network where the input is an ordered sequence where information from earlier in that sequence may be important later. So the network remembers it for a while. LSTM is a recurrent network where its output is used as an input for the next step. An LSTM network is composed of nodes and are connected to other nodes depending on its configuration. The activation function dictates how a certain node will produce an output. The two that I used here are the hyperbolic tangent or tan-h, which requires input values between -1 and 1, and the rectified linear unit or ReLU, which filters negative values as 0. Before we can apply the models, there needs to be transformation of the data. So for EMA, we transfer the data to stationary data through getting differences, and LSTM tan-h transformed used the data using min-max scaler. FB Profit and LSTM ReLU did not need to have transformed data. To decide which time series model to prioritize in the next phase of the project, I computed the errors for all the grids. The error I used is the RMSE because this ignores the direction of the difference between the forecast and the actual data. It also penalizes the differences which are larger. This table shows that LSTM with tan-h activation function performed best across all years, where its RMSE values are near 0. Now that we are done with our time series modeling, we will now proceed to spatial downscaling. Downscaling is the general name for a procedure to take information known at large scales to make predictions at local scales. In spatial downscaling, the information that we are processing is geographical data. So remember the wind map that I showed you earlier, the Global Wind Atlas map? We're gonna use that to perform spatial downscaling. We also have the visualization of the Era 5 data, which corresponds to the same time frame which the Global Wind Atlas team used to produce their map. You will notice that the map looks a bit rough. This is because of the resolution. To perform spatial downscaling, first we have two inputs, the GWA map and the Era 5 data. As explained earlier, one grid of Era 5 data corresponds to 10,000 grids of the GWA map. To explain the process simply, I cropped one grid of Era 5 data and its corresponding GWA map area. The Era 5 data here must be sliced to a higher resolution in order for the scaling factor to be computed. Once both inputs have the same resolution, it will be simple arithmetic to compute the scaling factor per pixel. Applying the factors involves a reverse direction. Now the input data are predicted values from the time series models. For example, the wind speed predictions for the year 2020 predicted by the LSTM, tan-h. We then multiply every grid of the predicted dataset with the corresponding factors. This process results to a set of pixels with higher resolution, the same resolution of the Global Wind Atlas map. So this procedure was applied to the 3000 grids of the predicted data and ran for almost 2 hours for every time series model output. Since LSTM tan-h produced the predictions with the lowest average RMSE of 1.15, I chose to prioritize its results in the spatial downscaling procedure. This is the output, the downscaled wind speed values in 2020 as predicted by the LSTM tan-h. But let's focus on the reds, the oranges, and the yellows. How do we check the success of our procedures? So in order for me to do that, I also map the error values for the time series model results of the LSTM. Yellows indicate higher error values, while greens indicate lower error values. I have found that the LSTM model predicted with higher error in areas that have higher wind speeds to begin with. those encircled in dark blue in both maps. On the other hand, there are also some areas with good wind speeds and have relatively low errors, encircled in red. However, if we are to consider only the time series model results pictured in the left, which is the raw LSTM tan age prediction, those two areas have predicted wind speeds lower than 6 meters per second. This means that both the downscaling input and the procedure itself played a big part in producing the resulting scaled map shown earlier. In conclusion, the resulting scaled map may serve as a rough estimate of wind speed values at a future time, at most 3 years. Aside from the LSTM TANH, both the LSTM ReLU and the Prophet methods performed well with errors not reaching 3. Spending at most 24 hours per model, the data science pipeline that I performed may be considered as a faster and a less resource-intensive alternative to the usual process of creating climate models. My recommendations for my fellow data scientists: consider exploring other time series models such as the ARIMA family of models, because wind speed data in some areas are seasonal in nature. Improve the following aspects of spatial downscaling: the procedure itself, because using a simple scaling factor might produce a somewhat overfitted result. Also improve the input to be used, because there are more sophisticated approaches of downscaling that may produce better results. What can you do as an individual? Keep yourself informed about your local area. Imagine if you were living in Ilocos Norte back when the wind farm was being planned. Would you have just accepted that a project this big is being implemented? How about in Visayas or in Mindanao? Wind energy is not the only renewable energy source suitable in the country. There are several others which deserve attention. If you're already in the industry, it is possible to apply these procedures with regards to these energy sources. And lastly, be an advocate for the earth. Push for policy changes by being an active part of the community, even in small ways. And that concludes my presentation. We're opening the floor for questions. Thank you.
Thank you very much, Pashu. That's a lot of information, but that is very good to give us a detailed explanation of your process. I'm sure that these data scientists and statisticians watching us today would be very pleased with your presentation. Yeah, so I'll begin by asking a question sent in by our guest speaker, David Dow. So according to him, in your study, your goal was to give a recommendation on where is the next best wind turbine location, right? And so he wants to know, is it as simple as predicting maximum wind, or are there other factors involved that should be considered, such as estimated cost, difficulty, and access? And if there are, how will you incorporate this in your model?
Hello, Julia. Good evening. Thank you for that question. Um, yes, there are other factors that will be considered if we are to use this method. So we will also consider wind density and also temperature, and uh, other factors such as the road connectedness. So most of the wind farms need infrastructure, so you have to have the grid closer. So you have, if that does not exist, so the grids must be cabled, I mean, closer to the wind farm that was selected.
Right, thanks, Bash. And I guess jumping to your methodology, just wondering, why did you choose to do time series analysis for predicting wind farm locations?
Okay. So actually, my initial was just the geospatial uh, aspect of the project, but with the push of my mentor, we did the time series as well, so that we can somehow give us an idea if we can predict the future map of the Philippines with regards to just wind speed. So that's my, yeah, that's why we pushed through the time series.
All right, thank you. And speaking of your mentor, JC, you have questions that you want to ask Bash?
Hi, hi, Pash. Good job on the presentation. So I'm really happy on how this turned out. No, from the start, no, when we have discussed this project, were your ideas up to this one. So I think this is a very ambitious project. No, time series forecasting. We did touch that during the boot camp. No, but I think with the way you applied this in your project is quite not quite what we have covered in the class. So I think you did more, no, you did expand on that. So could you like walk us through your time series process? And like I know that the ones that we have taught, the time series lessons that we have taught to the boot camp, no, just dealt with 1D data, one dimensional data, nothing like maps, nothing like 2D some things. So what was your process in expanding that to this one that this your project?
Okay, thank you, JC, for those kind words and that question. So actually, I really love geographical data since ever since undergrad. I did my thesis related to geospatial data. The time series part was a bit of a surprise for me because uh, since the grids have previous monthly observations, so it was quite intuitive to do it because if you have the monthly observations already and you have the methods already in place, so that's, I mean, it would be somehow what do you call this, technical or pedantic dogmatic to just apply the time series method. So from my end, maybe the thing that would be hard to imagine for others is the how how did that the geospatial and time series really merge, is that you should somehow understand how the grids I mean, how are they placed. So that's maybe one edge from my end. um, with regards to how I chose the time series methods, I tried only a few select grids first because I cannot just run all time series methods that I think of or you recommended. So I tried to just consider a few ones and tweak it so that if this is the lowest error that produces, so then we'll try it on the 3000. That's harder. I mean, that's the hardest part maybe, but perhaps that's for my computer to say. Yeah.
Mm. So, Pas, you mentioned that you had like 8,000 grids for your raw data. That's the ERA 5 data, right? Something like 8,000 grids for the Philippines.
Just
Is that correct?
3,195.
Okay. So you had your time series model and you picked, if I remember correctly, LSTM with a tangent arctangent activation. So how did you apply that model? No? So did you do that like one whole tuned model for all the grids, or did you tune that model for each of the grids?
No, I only tuned it to just two grids at first. So because I don't know because yeah, one thing is that the LSTM method was not taught in the sprint, but since, I mean, you exposed me to that somehow during the mentoring, so it was, I mean, technical to just understand. Maybe is a plus then that I had a programming background, so it was easy to just switch the parameters from, I mean, because you have to switch the LSTM is what do you call this, another thing of itself because
Mm.
you have to understand how the nodes will be, I mean, the data will be arranged according to the nodes that was configured for the LSTM. Maybe that's the hardest part for LSTM. Yeah, so
Mm.
after that, I just chose just two select grids of era data. So when around the 10 years, the 10 years of monthly observations. So yeah.
I think that's a good way to solve this problem because I guess saving setting, no, and finding separate set of tuned parameters, LSTM parameters per grid would like blow up in your memory. So good fix, no, Pash. I didn't actually ask that when we were consulting. No, so yeah, thank you for that clarification. No, so okay. ERA 5, no, the data set that I have recommended that for you to use, and also the raw data that the